Good day everyone, I'm your Mr. ATL and welcome back to my channel. So today's video, we're going to discuss about the law of sines, which is sine alpha over A equals sine beta over B equals sine gamma over C. So how it becomes like that? Okay, so we are going to derive the formula of the law of sines using these two oblique triangles, where the first oblique triangle is an acute triangle and the other one is an obtuse triangle. So the first thing that we're going to do is to construct an altitude from the angle gamma, which is perpendicular to the side C. Also, using the obtuse triangle, we're going to create an altitude to the extension of the side C. Okay, so how is that? I'm going to show you how to construct the altitude. Okay, so let us draw the altitude here. So this altitude is perpendicular to side C and this one is perpendicular to the extension. So this angle will form 180 degrees minus this angle alpha. Okay, so from this acute triangle, we can find or we can express that the sine of alpha is equal to the height over the hypotenuse B. And using the obtuse triangle, we can express that sine beta, okay, is equal to the height over the hypotenuse A, this side. We can also say that from this right triangle, sine 180 minus alpha equals to opposite, which is h over the hypotenuse B. So again, we have sine of 180 minus angle alpha equals to the opposite, which is h over the hypotenuse B. Also, from this right triangle, we have sine beta equals to h over A. From here, we can find that the value of h here, so since this is over 1, multiplying it, that will be h equals to b sine alpha. Also from here, h times 1 is h equals to a sine beta. Okay, so since h is equal to h, therefore we can say that b sine alpha equals to a sine beta. And dividing it both sides by ab, so we will cancel this b and we can get sine alpha over a is equal to, cancel this, sine beta over b. So we can get the two ratios, that sine alpha is equal to a and sine beta over b. In a similar manner, we can extend an altitude perpendicular from angle A, and we can find that sine gamma over C is equal to sine beta over B. And then equating these two expressions will lead us to the third of the law of sines, which is sine alpha over A. And that's how we get the law of sines. So let's have an example. Example number 1. Solve the triangle for which angle alpha equals 48 degrees, angle beta equals 52 degrees, and side A equals 24 units. So let us first illustrate or draw the triangle given these parts. Okay, so here it is. So there are given two angles and a side. So this kind of a triangle illustrates the AAS, or angle side. So we can apply the law of sine here. So as you can see, there is a missing value for this angle, or the angle gamma. So to find it, we all know that to find it, if we are going to add these three angles, it must be 180 degrees. So let us add angle A, or angle alpha, plus angle beta, plus angle gamma. It should be equals to 180 degrees. We have the given value for this angle, which is 48 degrees. Also for this angle, we have 52 degrees. And this is the missing angle. It should be equals to 180 degrees. Okay, so adding this up, it will give you 80 degrees. And this is still missing. It must be equal to 180 degrees. So solving for this angle, we will find that gamma equals to 180 degrees minus 80 degrees, or 100 degrees. Okay, so next, to find the measure of this side, which is B, and this one, which is side C, we can apply the law of sine. So from sine alpha over side A equals side beta over side B. So the value of alpha is 48, so let's substitute. The value of side A is 24. The value of sine beta, or beta, is 52 degrees over side B. So solving for this, we can find this side B. And how to do that? So let's cross multiply. So we will get B sine 48 degrees equals to 24 times sine 52 degrees. Okay, and then isolate this side B. We can divide it by sine 48 degrees. And let's use our calculator to solve for this part. So let us solve for this. We have 24 times sine of 52 degrees over sine of 48 degrees. Okay, so we will get 25.45 units. Again, that is 25.45. So the value of B is 25.45 units. Okay, so we already have the value of this angle and this side. So let's solve for the value of side C. To solve for the value of sine C, we can use the sine alpha over A equals to, we have sine gamma over C. So let's substitute. The value of angle alpha is 48 degrees over the value of side A is 24 equals to the value of sine of this angle, which is gamma, is 100. So that is sine of 100 degrees over, and that is what we are looking for, the value of side C. So to solve for that, let's just cross multiply. We will have C sine of 48 degrees equals to 24 times sine of 100. Then divide both sides by sine 48. So we can get that the value of side C, let's use our calculator first. Okay, so we need to compute for this. Okay, so what's that? 24 times sine of 100 divided by sine of 48 degrees. And that is 31.80. Again, the value of side C is 31.80. So we were able to find the value for side B, 25.45, the value of this angle 100 degrees, and the value of this side 31.80 units. Okay, let's proceed to the next example. Let's go to the next question. Find the unknown measures for this triangle. So there's a given oblique triangle. It is not a right triangle because there's no right angle on it. So we are going to find the value of this side, the side B, side A, and the angle gamma. So as you can see, in this triangle, it's an example of an ASA or angle side angle case because the measure of the two angles and a side length are given, and this side is not opposite of these two angles. Okay, so we can find the value of this angle. So again, this is an example of angle side angle case of an oblique triangle. So to find the value of this angle gamma, we're going to subtract 180 degrees by the sum of these two given angles, which is angle A or 80 degrees, angle alpha, plus the angle beta of 32 degrees. So adding them, it will give us how many? That is 112. So if that is 112, subtract by 180 degrees, that is, so let's write it first, 112. So that will be 68 degrees. So this is the value of angle gamma, 68 degrees. So let's write it there. Another one, we need to find the value of side B or side A. So this is the time that we will be using the law of sines. With the unknown side, or given this side C, we can write, or we can use the sine beta over B equals to sine gamma over C. The value of this is 32 degrees, so sine 32 degrees over the side B is unknown, and then sine of gamma, which is 68 degrees, sine 68, over the value of side C, 17 miles. Okay, solving for this, we will get B sine 68 degrees equals to 17 times sine 32 degrees. Dividing them both sides by sine 68 degrees. So we can now solve for the value of the side B. So using our calculator, we will compute this expression. So we need a fraction, 17 times sine 32 degrees. And then divided by sine of 68 degrees. So that's what we can get, 9.72 miles. Okay, we were able to find the value of the side B, 9.72 miles. Next, let us find for the value of side A. So we have sine alpha over A equals sine gamma over side C. So let's substitute. We have alpha is 80 degrees, our side A is unknown, our gamma is 68 degrees, and then our side C is 17 miles. So again, let's solve. We have A sine of 68 degrees equals to 17 times sine 80 degrees. Divide both sides by sine 68 degrees. Sine 68 degrees. So we can get, let's cancel this first. So using our calculator, we can find out that the value of side A is how many? So we need a fraction. 17 times sine of 68, sine of 80 close divided by sine of 68 degrees. So we have the value of side A, which is 18.06 miles. Okay, so let's write it there. We have 18.06 miles. So we were able to solve the given measures or the unknown measures for this triangle. Example number 3. A curtain on the window was tied at the bottom part, forming an inverted isosceles triangle. The angle at the vertex located in the tied part is 30 degrees and its opposite side is 5 feet. Find the length of the remaining sides. So let us draw first the triangle that is being said on the problem. Okay, so this is now the given triangle there. So it's an oblique triangle. Actually, we can solve this using the oblique triangle and using the SOHCAHTOA, or by the use of solving the right triangle. So how is that? Let me show you first the way on how I can solve this using the oblique triangle. So since this is an isosceles triangle, this side or these two sides are congruent, and this is the part that we are looking for. So if they are congruent, the opposite angle are also congruent. Okay, so if this is 30 degrees, since the sum of the angles of a triangle is 180 degrees, we can say that 100, or let's use angle A here. So this is A, this is also A, since they are having same measurement. Okay, now, so we have angle A plus angle A plus 30 degrees equals to 180 degrees. Okay, so A plus A is 2A equals to 180 degrees minus 30 degrees. 2A now equals to 150. So dividing it by 2, we can get that angle A is 75 degrees. So therefore, this angle measures 75 degrees. Okay, now, let us now use the law of sine. So using the law of sines, we have, let's say this is angle B. We have here angle B, or sine B over the side B is 5. So let's use it. Let us write first the formula. Sine B over B equals to sine A over X, since this is the opposite side of the angle A. So substitute now the given. We have sine of 30 degrees over B, which is 5, equals to sine of 75 degrees over X, and this is what we're looking for. So solving for this, we will get X sine of 30 degrees equals to 5 times sine of 75 degrees. Now divide it both sides by sine 30 degrees. Sine 30 degrees. This will be cancelled out and X will be equal to, let's use our calculator. So we have 5 times sine of 75 divided by sine of 30. Oops. Divided by sine 30. So we will get 9.69 feet. So again, this is 9.69 feet. Okay, so this is now our final answer. Now let us use now the SOHCAHTOA in solving for the same side or the side X. So if that is the case, using the right triangle, we're going to draw an altitude from this vertex which is perpendicular to the side which measures 5 feet. Okay, so let me draw an altitude here. Okay, so if this is now our altitude and this is perpendicular to this side, we can form now a right angle and also a right triangle. So in a right triangle like this, where this is the right angle, this is your side X, and we have 75 degrees and 15 degrees. It is now being divided into two. Okay, so if this is 5 feet, then this is now 2.5 feet. Okay, so now let us apply the SOHCAHTOA. By the use of this angle 75 degrees, or even this angle 15 degrees. Let us use the 75 first. We have the given here is the if this angle that we are going to use, we have the adjacent side and the hypotenuse. So therefore we will use the cosine or ka. So cosine of 75 degrees equals to 2.5 divided by our X. But if we are going to use the angle which measures 15 degrees, we need to use this side or the opposite side of 2.5 feet and the hypotenuse. So we will use O and H, or SO, which represents sine function. So sine 15 degrees equals to 2.5 feet divided by our hypotenuse is X. So let us solve first for this one. This is over 1. We have X cosine of 75 degrees equals to 2.5. Then divide both sides by cosine 75 degrees. So we will use our calculator and then let's write our answer there. So we have 2.5 divided by cosine of 75 degrees. So we have 9.69 feet also. So 9.69 feet. Same answer. Next, using this sine 15 degrees, this is over 1, then cross multiply, we have X sine of 15 degrees equals to 2.5 feet. Then divide both sides by sine 15 degrees. Okay, so let's use our calculator to solve for this one. So we have 2.5 feet, then divided by sine 15 degrees. So obviously, we will obtain the same answer of 9.69 feet. Okay, so whatever method you want to use, it's okay, for as long as you're not going to violate any rules in mathematics. Okay, so let's have another example. Okay, so last example, we have number 4. From a certain point, the angle of elevation of the top of the flagpole is 40 degrees. From the point 80 meters nearer to the flagpole, the angle of elevation is 70 degrees. So find the height of the flagpole. Okay, so let us draw first the given objects there. So we have flagpole. Okay, so there it is. This is our flagpole. And let us draw first the next thing that we're going to draw is the point which is which has a 40 degrees for the angle of elevation. Okay, so this is the point and the angle elevation formed is 40 degrees. From the point 80 meters nearer to the flagpole, nearer, so it's going closer to the flagpole. So it measures 80 meters. So from here, and this one is 80 meters. So the angle of elevation is 70 degrees. Okay? Okay, so now let us find the height of the flagpole, and let's denote that as H. Okay, so there is a right angle there, and we can form the right triangle. So to find the measure of this, of the height of the flagpole, we may use the SOHCAHTOA. But we do not have value for this and for the hypotenuse. But as you can see, if this is 70 degrees, since this one will form a straight angle, then this one should be 110 degrees to complete the 180 degrees there, since the measure of a straight angle is 180 degrees. And if this is 40, this is 110, adding them, that is 150. And we need more 30 degrees, since the sum of the measure or sum of the interior angles is 180 degrees, it must be 30 degrees. So now, what are we going to do next? Okay, we can form another triangle, which is the oblique triangle. Okay, and we can find the measure of this one and also this one. But this one is not useful if you're going to use the SOHCAHTOA on this right triangle. But this one will be useful to solve for the height of the given flagpole. So let us now use the variable x in finding the measure of this hypotenuse for the right triangle. Using the law of sines, we need to use this angle, which is sine 40 degrees over the opposite side is x, equals to, there's a given measure for this side, so let us use this one, sine 30 degrees over 80 meters. So let us solve for the value of side x, and we can apply it there by finding the measure of the height of the flagpole. So we can use, we will multiply this. We have x sine 30 degrees equals to 80 times sine 40 degrees. Divide both sides by sine 30 degrees. So cancel out, we will get how many? So we have 80 multiplied by, let's place it there. So 80 multiplied by sine 40 degrees divided by sine 30 degrees. Okay, we will get 102.85 meters. And that is only the measure of the hypotenuse of the given right triangle. But we are looking for this side, okay, for the height of the flagpole. So given the, so using the angle 70 degrees, given that the opposite side, or finding the measure of the opposite side, which is height, and given also the hypotenuse, so opposite and the hypotenuse, we will use the sine function. So sine of 70 degrees equals to the height divided by the hypotenuse, 102.85 meters. So solving for h, we will get h equals to 102.85 times the sine of 70 degrees. So let's use our calculator once again. So this is already the answer. Let's multiply it by, so multiply by 85, or sine, sorry, multiply by sine 70 degrees. Okay, so what are we going to get? We have 96.64 meters. So therefore, the height of the flagpole measures 96.64 meters. Okay, so it's 96.64 meters. Okay, so that's all for today. I hope you enjoy learning about the law of sines. And before I end up my video, I would like to give my special thanks to Mr. Eldrin Dalican, and I hope you learned something. Goodbye!